Dr. Ian Parker engaged in paper industry research for nearly 40 years, first working for Australian paper manufacturers and then at Monash University, where there was established a master's coursework program in pulping, paper making, and paper properties. This morning, Ian will share how timber logs are transformed into the final paper product that end up in our homes for everyday use. I'm Ian Bunston. Welcome to Monday Matters. Welcome, Ian. Great to have a chat with you this morning.
Good to be with you, Ian.
Now, Ian, in 1970, you graduated with a PhD in physics in an area totally unrelated to paper. What happened?
Well, I decided that I didn't want to stay in a university and that I'd like to see what industry was like. Australian Paper Manufacturers, or APM, offered me a position in the research labs, and a bonus was they were new labs and they're on the banks of the Yarra River.
Very nice location for you to be in. Now, let's go straight to an A4 piece of paper. Tell us how A4 paper is produced, the type that ends up in our printers. In fact, I can see a printer just behind you on your left.
That's correct. And perhaps if you put up that photo, Ian,
Sure.
get a bit of a picture of what paper is about. In general definition of paper is made up of a sheet material from a lot of slender fibers, and you can see what it looks like there on the screen. And these fibers stick naturally to each other and to water. The scale of that, the width of the picture there is about 1 millimetre. So you can take that down there, Ian, thanks. Most types of paper use a very similar process to the process used to make A4 paper, but there are lots of tweaks along the way. And a lot of those I won't talk about because they're fine detail. And to get an idea of the cost of equipment, for equipment that's going to make A4 paper from logs, you're looking at well over $1 billion. Now, when we start with the logs that come into the mill, they're first chipped, and we have to even decide what sort of logs we're going to use. Now, for A4 paper, and we want to get uniformity in an A4 sheet and also a certain amount of opacity. And that says, let's use eucalypts. So eucalypts are the ideal material for A4 paper, although you could use other hardwoods. Now we're going to cook the chips just like you do in the kitchen. However, we're not trying to make something, we're trying to break something. So we use water and chemicals, and these separate the fibers, because in the wood they're all glued together with some glue, but we want them separated to make the sheet of paper. But as you know, an A4 sheet is white. Now, fibers are not going to automatically make a white sheet of paper, so we have to go to our next step, which is to bleach the fibers. After bleaching them, we're going to then pump those fibers across to the paper mill area. And the first process in the paper mill area is to massage the fibers. The more we massage the fibers, the stronger the sheet of paper, but the less opaque. So we've got to strike a balance, which happens with many paper properties. The more we process it, one property goes up, another property comes down. We're now going to pump the fibers in water to the paper machine proper. And we're going to dilute the fibers to about 1% by weight of fiber to 99% of water. Now we do this so that we can disperse the fibers uniformly. If we go to higher concentrations of fibers, we can't distribute them uniformly throughout the water. And most of the rest of the process is just removing the water. We've got to keep the fiber suspension, as we call it, fibers in water. We need to keep it agitated to keep the fibers dispersed. just before we start to remove the water, obviously we've got the fibre suspension flowing in a pipe, but we want a long, wide, thin jet so that we make a sheet of paper. We don't want a sheet of paper that's got a profile like that. So it might be up to 5 meters across. We've got to make this very uniform jet of fibre suspension. And it's got to have the right amount of fibres in there to make what is usually, for A4 paper, 80 grams per square metre. AGSM you see on the edge of your packets of A4 paper. We've got to keep the suspension agitated all the time. And as it is extruded out, it's got to come out at high speed because it's going to come out onto a plastic mesh. And that plastic mesh will be moving at something like 1,000 meters a minute. So the jet's got to come out at about that same speed. So now the rest of our process is just removal of water with a lot of tweaks along the way that influence the quality of the paper. And the first way we get rid of the water, of course, is the easiest, cheapest way, as some just drains out through that plastic mesh. But it's not long before that slows down. So next cheapest way of getting the water out is to suck it out. So we provide suction, removing some more water, and we end up with it about 20% fibre, 80% water. Next cheapest way is to do something like they did on those old Hoover washing machines where they had ringers on top. So you're going to press the water out. But these are enormous rolls that are used to provide the pressure you need to press water out of the paper. So after we've applied this pressure, we're going to end up with about 50-50 fibre water. So it's still a lot of water there. We have to then, and the only way we can get the rest of the water out is to use evaporation. So the paper web that's still very wet, but it's strong, goes up and down around lots of steam heated drums. And that's the biggest part of the machine, the longest part of the machine, is these dryer drums, because it takes many passes over these dryers to evaporate most of the rest of the water. We're only going to dry it out to about 7%, because if I hold that piece of paper up in the atmosphere, it's going to pick up water to about 7% if I dried it out to 2%. No point going down to 2% because it's going to come up to 7% anyway.
Yeah.
So 7% water, that's where we get to. So we've now got to the end of the paper machine, and we have a gauge that runs to and fro across the paper web, measuring the moisture content and measuring the grammage, that is 80 grams per square metre. And the signals from that gauge are fed back to a computer, and that makes small changes on the machine to either increase temperature of the dryers or reduce them, or to slightly increase the flow out of in the jet that's coming out of the early part of the paper machine. And so we use our computer to trim the paper web so that it's got the properties that we want. Now, people talk about using computers to do clever things these days. We've been doing that in the paper industry for 50 years. And when I was working at the paper mill for a couple of years, one of my tasks was to do some modification on the computer program that was controlling the valve that controls the amount of fibre coming forward. We roll the paper up into a big reel, and that big reel then, after a time, we have to break it, of course. We can't go on forever. So you snap that reel of paper every now and then to start a new one. And someone comes along and takes a sample off the outside and does more testing in the lab to make sure it meets the quality. And of course, the rest of the process is then just cutting it up, putting it into packets and selling your A4 paper.
Well, then I was just thinking that if I was doing a colouring exercise with my grandchild, and they asked me the question, Granddad, how did this paper, come into being? I'd really need a much simpler explanation. I have no idea it was so complicated or the process of going through that. So maybe that's a discussion, Ian, for another time. The simple
Mm.
process of getting to this paper production. But look, I'm thinking about, say, tissues, paper toweling, toilet paper. I mean, I've always thought, how do they get to the right strength of a paper item like that?
Well, strength is not the prime property that they're aiming for. Customers tend to buy, most customers tend to buy on softness. So they deliberately reduce the strength of the tissues to get softness. And if you want to increase the strength, you just lay a few sheets over each other, and that increases the strength, of course. So you can buy 2-ply tissues or 3-ply or 4-ply. So depending on uh, how strong you want it to be. And of course, the rest of it comes into your technique, the way in which you use the paper in.
Okay, we might not go into that space, but look, I'm just thinking of, say, cardboard packaging, Ian. It's another type of paper that we see and use daily.
Mm.
Egg cartons, for instance. Is that then more layers of paper? Is that the way they get it stronger and thicker?
Air cartons. They don't meet the definition of paper, and paper is a sheet material. These are just paper mache. So the process is to have a mold. You just suck the water through the mold, which has got a mesh on it. The mesh catches the fibers, and you end up with a molded product, not paper.
Okay, I stand to be corrected. As I reflect on the process that you've gone through, which is very complicated, really, um, what are the main environmental impacts of producing paper?
Just first, I might mention that our major products are packaging materials. Your,
Yeah.
your raised packaging when you talked about packaging of eggs, but when we're buying things online, they come in packages. Fruit and vegetables come into the supermarket or person who's selling just fruit and vegetables come in boxes. So these are the major products. And you're really after strength in this case, not uniformity. So for that sort of product, we tend to use the pine. So just to give you an idea, that's a pine fibre compared with a eucalypt fibre. So very different. We're after strength, so the pine fibre. And you're probably aware that many boxes of corrugated material in the centre. So you've got one layer of paper or paper board as we call it because it's heavy and a corrugated material in the middle. And the further apart, the stiffer the material becomes. You mentioned environmental issues. Well, that's really a good story for paper. Paper's using a renewable resource, and over 80% of our paper is recycled in this country. So a highly recyclable material. With the chemical processes that are used to separate the fibres, the chemicals go back into a process that actually regenerates the original chemicals. So we don't have to dump any chemicals, we just regenerate them. We do burn the material that comes out of the logs of wood that we don't use, and that's used to generate steam for drying the paper, and if we got excess, it's used to generate electricity. Unlike the home where you might have a chimney which is emitting a few particles and smelling out the neighbours, the paper mill can afford to have clever equipment to remove all that particulate material and remove most of the smell. Unfortunately, the nose is very sensitive to some particular gases, so you can remove 99.99% of the gaseous material and still smell it. And the water that you use, the bulk of that's recycled. going just round and round the system. You do have to bleed out a little bit every now and then, otherwise you build up material that's going to rust your equipment. And that goes to ponds where you aerate. And then at Merivale Mill, for example, down near Traralgon, they have great big ponds that just allow natural aeration as well. Just as an aside, to the bleach material, at least at one stage in the past, used a mercury process to produce the chlorine that was used to bleach. And I understand that some students from Monash University went and measured the mercury content upstream from the mill and downstream from the mill. And in fact, downstream had a lower mercury content than upstream because the mill's cleaning up the water before it's used.
Mm. So, Ian, I've got to ask you this question. I mean, paper is such an integral part of our lives. Well, can you imagine what life would be like without paper?
Well, let's take a few of the examples. You'd have to buy a bidet, Ian, and it's quite common in some parts of the world, Japan and Scandinavia, but
Yep.
most of our people here don't use bidets. And in fact, our bathrooms, toilets are not big enough to put them in. And as far as packaging goes, imagine how you're going to package all your boxes of goods that are coming in. Even refrigerators come in big cardboard boxes, essentially. So you'd have to produce, well, what do you got? You're just about left with plastics. And think of the non-renewable resource and disposal problems. So that's be a big issue. So yeah, you'd really have to think about now, how am I going to print in my printer? You've got to have a material that's going to take print. That's got to be stiff enough to go through. You can't use a very thin plastic material or something. It wouldn't be stiff enough to feed it through the printer. So a lot of qualities that you need in the papers. So very hard to replace paper.
Can't imagine what it would actually be like. It's such an everyday thing that we just take for granted, the use of paper
Mm.
and its presence in our lives. And
Good.
look, I want to thank you for sharing your knowledge, your story of what it's been like for you being involved in the paper industry for so many years. And I'm thinking of a slogan that kind of sums up the paper, the everyday material that holds our world together. It's really quite remarkable, the vital place that it plays in our lives. And thank you very much for being our guest here at Monday Matters today.
That's my pleasure, Ian. And if you want to know the fine detail, just come along and I'll talk to you further.